Hi, my name is Marisa Koopman.
My name is Quang Phung.
So a graphical user interface, or short GUI, is the visual part of a software system that allows the user to interact with it in an intuitive way. So for example, through buttons, icons, maps, or other elements. The project deals with a wide range of technical components and integrates different data sets, or especially environmental data sets, which are in most cases very complex and not directly usable or interpretable by the end users. The GUI, you can say, acts as a bridge between the underlying data infrastructure and the people who need to work with the data at the end, for example, scientists or policymakers. Small lakes in and around Berlin, they lack systematic monitoring. Currently, decision makers do not have access to the information that they need to take targeted actions to preserve or improve the conditions of these small lakes, for example, on water quality or water availability. And the Splasboard was developed to provide an easy to understand and visually engaging overview of the current state of small lakes in Berlin. The second tool we developed and designed is the BioConnect tool for functional landscape connectivity, which is the ability for species to move between different habitats. This is also critical for biodiversity and ecosystem resilience. And this connectivity data is also a key factor in land use planning. But this connectivity data is typically only available at a broad geographic scale, for example, at national level. And that makes it very difficult for local and regional stakeholders to use it. So the BioConnect tool addresses this challenge by creating a new method to assess this connectivity at a regional or local scale using multiple data sources like remote sensing, IoT data, or also citizen science data.
It used the front-end library React to build the interface in a modular and efficient way by breaking the whole application down into smaller and reusable components. So when the component loads, it will fetches the data from multiple sources, internal and external, internal via OpenDash and external via various service providers like web map services, and then display it within an interactive and user-friendly interface. The data will be easily accessed and shared across different widgets, such as the data diagrams, for example. And these widgets, these self-contained software elements, are then integrated into larger components to create a more complex and dynamic views. So for pilot 1, the component is responsible for displaying a pool of selected lakes or water bodies around Berlin on an interactive map. It shows both historical data such as like water level, water temperature, air temperature, etc. And also prediction data like forecast water level. In addition to these time series, the component also displays water quality indicators such as the water quality index. For pilot 2, the component focus more on the complex, more on the connectivity index in the Catalonia region. It displays this index on the map, and alongside with it other useful information such as satellite imagery and species occurrence data. Users can browse the information on the map as well as interact with the map by drawing or selecting a specific region. And thus they can also define a desired land use scenario. So for example, land use change from forest to crops, or maybe from crops to built area. And the goal is to recalculate the connectivity index based on this user input. And then it could be shown side by side, the before and then the after. Component is designed to be flexible and modular, making it highly adaptable for users beyond the AD4GD project. And because of this architecture, the component can be repurposed, for example, for wide ranges of use cases, like from environmental monitoring platforms to analysis dashboards, or even Internet of Things based applications where time series data from various sources needs to be visualized effectively.